kids. This past week we talked about the Pythagorean Theorem in class. Actually, the past 2 weeks we've been talking about it. And this video is just to give you some kind of supplemental help. So this video is not intended to teach you exactly how we did in class, because in class we did a lot of hands-on learning, but this is just some extra help for you. Alright, if you look here, Pythagorean Theorem, this is the formula, which we use the proof to talk about y, and it's a squared plus b squared is c squared. A and B represent your legs of the triangle, and C represents your hypotenuse. Oop. And that's how you spell it, hypotenuse, okay? Now, what's really important here is that the hypotenuse always goes after the equal sign. A and B are just your legs, and it doesn't really matter the order that they go in as long as you just put the legs on this side of the equation. So your hypotenuse, let's talk about, well, how do we know which one is the hypotenuse? Your hypotenuse is the one that is always across from your 90-degree angle. All right? Well, let's say that I give you a triangle, but I don't tell you where the 90-degree angle is. Well, the 90-degree angle is always going to be at the intersection of the perpendicular lines. So here, A and B are perpendicular because they form an L. So my 90-degree angle would be right here. And once again, right across is my hypotenuse. Another thing that a student said is that they look to see where the box is pointing, and they say, well, where the box points, that's where your hypotenuse is. I thought that was a pretty clever way to figure out where the hypotenuse is. So here's your 4 steps. The first step, set up your equation. Second, square the numbers. Third, solve for x. Fourth, take the square root of the number. So let's go ahead and do some practice examples. And in these examples, we're not going to work the triangles or solve the triangles. All we're going to do is just identify where is the hypotenuse at. Now, the sides that I give you right here, these are side numbers. They are not values. So which one do you think, or which side do you think is the hypotenuse? Side 1, side 2, or side 3? If you said side 3, you are correct, because it's straight across from your 90. Let's look at this triangle. Which one do you think represents your hypotenuse? Side 1, 2, or 3? If you said side 3, you are correct. Here, straight across from the 90 is side 1, so that's our hypotenuse. And here, straight across from the 90 is side 2, so that is our hypotenuse. And once again, if it's not the hypotenuse, they are the legs of the triangle. So basically, your hypotenuse is what represents C, and your other 2 sides are A and B. And it doesn't matter which one you label A or which one you label B. Does not matter. Okay? Let's go ahead and practice solving a triangle. And I just want to do number 1 with you. We're not going to do all of these, but number 1, first you want to set up your equation, and you go straight across from your 90, and you see that x is the side that is going to be my hypotenuse. So this would be C, and this, it doesn't matter which one is A and which one is B, but I'm just going to say that's A and that's B. So to set up my equation, I would have, after the equal sign, I always do that first, your C, which is x squared. And then you're going to have 5 squared plus 7 squared equals x squared. So square your numbers. You get 25 plus 49 equals x squared. Then we're going to go ahead and we're going to add them together. And 25 plus 49 is going to give us 67. Yeah. Oh, I'm sorry, I was way off. It's not 67. It actually gives us 74. Right? And then all we got to do is just take the square root. Now, normally when we take the square root, remember we talked about how this is going to be a positive or a negative in the end. So for this problem, when you take the square root of 74, and we're just going to round, and I told you how to put it in your calculator, or we could do it in our head. But whenever we round, we say that it is about, and it's going to really be plus or minus 8.6. However, the answer is only positive 8.6, because can a length ever be negative? No, a length always has to be positive. If a length was negative, then it wouldn't exist. So whenever we're solving these, I'm going to stop putting plus or minus, but just remember that the final answer is positive. But if I was solving the equation without it being a triangle, I would still have plus or minus. Okay, let's go ahead and look at number 3. So straight across from your 90 is your hypotenuse, so that would be my C. I'm going to label this A. I'm going to label this B. So I would have, after my equal sign, 15 squared. And before my equal sign, doesn't matter which one you put first, I'll just do x squared plus 2 squared. So x squared is still x squared. 2 squared is going to be 4. 15 squared is going to be 225. Then we're going to go ahead and we got to solve for x. So I need to subtract 4 from both sides in order to isolate my variable. And I'm going to get 221. And then I'm going to take the square root of each side. Once again, if this was a normal problem, I would be putting plus or minus. But since it's dealing with sides of a triangle, my final answer is always positive. So the square root of 221, if you put that in your calculator, should come out to be about 14.9. Okay? And these are basically the two ways that the triangle can be set up if it's a right triangle like this. Okay, we're going to go ahead and we're going to move on to the next page. And the next page, it had some pictures for you. Now, I know this picture is a little bit special looking, but I created it, so that's why it looks a little weird. But my question says, how far is the man away from the tree? Notice I do not give you where the right angle is, but if I told you that this was perpendicular, these two sides, then that means this would be 90. So across from your 90 is 16. So it's going to be equals 16 squared, because that's my C. And it doesn't matter which one I want to say is A or B. I'm just going to do it that way. Okay, so once again, we're going to go ahead and we're going to square. So 12 squared is 144. 16 squared is 256. Then I'm going to go ahead and I'm going to subtract 144 from each side. So x squared equals, that would be 2, that's going to be 1, and that's going to be 1. Then I'm going to take the square root of each side. Once again, whenever you take the square root, technically you should be putting plus or minus, but we don't do that because it's triangle problems. And we're going to have about 10.6. And we want to say our units. And our units here in the picture is feet. So our answer needs to be feet. So basically the answer is the man is 10.6 feet away from the tree. Let's try another one. All right, let's actually go back. Sorry. We'll do this one. A magician is standing on top of a building 60 feet above the ground. So I'm going to go ahead and just draw my picture. So there's my building. Okay, now my magician, he's going to look a little fun. I'm going to put a cape because I don't know. When I think of magicians, I think of capes. Ooh, he's smiling. Give him some hair. Okay, so he's standing on top of a building that is 60 feet above the ground. Okay, and here's the ground. Boop, 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 boop. The crowd is on the ground looking up at him 15 feet away from the building. So let's imagine that every single member of the crowd, they are all standing in one cluster. And I know this story problem isn't super realistic because the crowd's going to be standing all over the place. They're not going to be standing in one spot. But let's just say for purposes of this problem that there's one person in the crowd and this person is standing right here. And they are 15 feet away from him. So if the magician falls at a right angle toward the crowd. So I had to put right angle toward the toward the crowd in order to imply that it's going to be a Pythagorean theorem. So this is how he's falling. And you can see that your perpendicular lines would be right here. How far will his fall be? So to determine how far his fall is, this would be our x because we don't know that. And once again, it says do not try this at home. So please do not try this at home. Then we're just going to go ahead and solve once again. Across from your box is your 90, so equals x squared. So 15 squared plus 60 squared equals x squared. 15 squared is 225 plus, that's going to be 3600 equals, I'm sorry, that looks crazy. Let me erase that. Now for this one, everything is on this side. So I really just need to combine like terms. There's nothing that I need to move over in order to isolate x because it's already isolated. And when I add that together, I get 3,825 equals x squared. And then when I take the square root of that, I'm going to get about 61.8 feet. Okay. Once again, this problem isn't very realistic, and I probably should have said something better than a right angle towards the crowd, but I was doing the best with what I had. All right. So let's go ahead and let's look at a few more story examples. So here's another problem, and this problem is probably a little bit better than our other one we just looked at, but it says, to get from point A to point B, you must avoid walking through a pond. So, let me say that here's my pond, and here's point A, and here's point B. So I have to avoid, like to get there, I have to avoid walking through the pond. To avoid the pond, you must walk 34 meters south and 41 meters east. So to get from this point to this point, that means that I have to walk 34 meters south, and 34 meters south just means you go down. And 41 meters east would mean that you went 41 to the right. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? So if I could walk on water, how many would be saved? Well, first I need to figure out what is my length here. Once again, this is where your L shape is, so that's your right angle. We're going to set up our equation, and it's going to be equals x squared, so that's the hypotenuse, and 34 squared plus 41 squared. So if we go ahead and we add these together, we're going to get 2,837 equals x squared. And I just skipped a step. If you square both of these and then you add them together, this is it. That's their sum. So then when you take the square root of this answer, you're going to get about 53.3 meters. So the length to cut through the pond would be 53.3 meters. Now, did it say how far would he travel? No, it actually said to the nearest meter, how many meters would be saved if it were possible to walk through the pond. So I'm not asking you how many meters is my walk through the pond, but I'm asking you how many would be saved. So the word saved actually implies that I want to know how far this would be normally, and all you would do is just add up those two lengths. So that would be 75 meters, because 34 plus 41, 75. So that's what I walk originally. But if I could walk through water, if that were possible, then I'd only have to walk 53.3 meters. So I just want to know how many are saved. So 75 minus 53.3, and that's going to give us about 21.7 meters. And that, my friends, is your final answer. Let's go ahead and let's do one more. A baseball diamond is a square with sides of 90 feet. So I'm going to put 90, 90, 90, 90. What is the shortest distance to the nearest tenth of a foot between first base and third base? So I'm going to say this is first base, and this is third base. Okay? And what is the shortest distance between these two? So the shortest distance would be if I ran that way. Because if I ran this and this, or then if I ran this and this, I'm actually running farther. And here's another hint. Shortest distance always implies hypotenuse. Just like the word diagonal implies hypotenuse, so does shortest distance. Okay, so we're going to set up our equation. There's our 90-degree angle. So I want to figure that out. So 90 squared plus 90 squared equals x squared. And after you square both of them and you find the sum, your sum should be 16,200. Then take the square root. And your answer should be about 127 0.3 feet. So that's the shortest distance. Now, one thing I do want to talk about real quick, I'm just going to, if I could physically pick this up and plop it right here, I'm just going to rotate it. I'm going to write this real quick. This is what we found. And we said that each of these sides were 90, because I want to talk about something real quick with you. Okay, whenever I said the shortest distance means if I'm cutting across. This, however, is the longest side of the triangle. The hypotenuse is always the longest side, but it's the shortest distance, and there's a difference. Because if I were to walk from here to get from point A to point B, if I were to walk this way, I would do 180 feet. But if I'm able to cut across diagonally, I'm at 127.3 feet. So it's the shortest distance from point A to point B. However, if we're just looking at the individual triangle, the hypotenuse should always be your largest number. And that's going to bring me into reviewing with you how to determine if something is a right triangle. Okay, to determine if something is a right triangle, we use Pythagorean Theorem because a right triangle implies that you can apply the Pythagorean Theorem to this triangle. So from what I just told you, that the largest side should be your hypotenuse. And that's what it says right here. The largest value goes in place of C in Pythagorean Theorem, which we just talked about why. So let's go ahead and we're going to skip on down. We're actually going to do this example. Okay? And basically what it's saying, the largest needs to be C. So the other ones, it doesn't matter which one is A or B, but that's going to be your legs. So you would have 5 squared plus 7 squared equals 8 squared. If this is a right triangle, the sum of A and B should equal my C. If it does, it's right. If it doesn't, it's not a right triangle. So 5 squared is 25, 7 squared is 49, equals 8 squared is 64. So now we just add together 25 and 49. And when you add 25 and 49, you get 74. So is that the same as 64? No, it's not. And mathematically, we show that by drawing a line through our equal sign. So since it does not equal the same, that means that this does not form a right triangle. So it's not a right triangle. All right, let's go ahead and go to this last example. And the last example involves radicals. Okay? And if we were looking at this and we wanted to determine what is the largest side, the square root of 55 is going to be about around 7.4 because it's in between 7 and 8. So it's automatically smaller than this one. And the square root of 77 would be in between 8 and 9. All right? So it's smaller than A also. So that means basically that this would actually be our C. And actually, when I look at this problem a little bit more, I think what they wanted you to do, so let's scratch this out, sorry. This really should have been your C. But let's go ahead and just work the problem exactly how they gave it to us. So we would have 11 squared plus the square root of 55 squared should equal the square root of 77 squared. But I really want you to notice that if I didn't tell you what A, B, and C were, your C really should have been 11. Okay, so 11 squared is 121, and we talked about in class how the square root of 55 squared is just plain old 55. It cancels each other out. Just like the square root of 77 squared is going to be 77. And it's very simple to see from here that obviously 121 plus 55 will not equal 77, so it's not a right triangle. Okay? Now let me show you one that will work actually, that way you can see what it should look like if it does work. So let's do 3, 4, and 5. Obviously 5 would have to be our C because that's the largest. So we would have 3 squared plus 4 squared should equal 5 squared. 3 squared is 9, 4 squared is 16, and that should equal 25. 9 plus 16 is in fact 25. So that means that 3, 4, and 5, those sides would form a perfect right triangle. And moving on, we talked about the applications of a right triangle, and we can use Pythagorean theorem to figure out distance between 2 points. So, for example, if I gave you this right here and I said, what is the distance between negative 2, 1 and 4, 3, you could easily do Pythagorean Theorem with that. And as we were doing it, we would just count the distance. And I want to get from this point to here. So I say, how far do I go over? And then how many do I go up to reach this point? So I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I go over 12. And then I go up 1, 2, 3, 4 units. This is your x. There's your right triangle because it makes a perpendicular line. So you would have 4 squared plus 12 squared should equal x squared. So 16 plus 144 should equal x squared. And if you add those together, you're going to get 160 equals x squared. And then we're going to take the square root. And the square root of 160 is about 12.6. So that's how long this length is. Okay, let's do one more. And I actually want to do this one. This one's a little bit different because it doesn't count by ones like our other example. This one actually counts by twos. So if we look right here, this is supposed to be at 3. So from 3 to 4, there's a difference of 1. And from 4 to 6 to reach up here, there's a difference of 2. So this whole side is 3 in length. And then it goes over, not 1, but 2 because of how it's counted. And this would be where your hypotenuse is. So 3 squared plus 2 squared equals x squared. So 9 plus 4 equals x squared. So 13 equals x squared. And when you take the square root of 13, you should get about 3.6. Okay? And the last thing I want to talk with y'all about today is how to find the length of a 3D box, okay? And this would apply like if we talked about how if we wanted to send something to UPS and we put a baton in there, how long could our baton be? And this right here would be the length of the baton. But what's cool about this is that there's actually 2 triangles. We have our little bitty triangle down here and then our big triangle. So the fact that if we were to just put a baton in a box, it would actually form 2 triangles, okay? So let's talk about our first triangle. First, in order to figure this out, I'm going to call this y, I would need to find my smallest triangle. And let's talk about y real quick. Because in order to figure out what this length is, I have to know this squared plus this squared. That's your right, and this is your right. Okay, so let's go ahead and do the bottom one. So that would be 10 squared plus 2 square roots of 11 squared equals x squared. So 100 plus, and we square this number 4 times. Remember, this cancels, so that was 11. So we said that would be 44 in class. Equals x squared. 100 plus 44 is 144. And the square root of 144 is 12. Exactly 12. So that means this guy is no longer x, but I'm actually going to say he is 12 centimeters long. Okay, now that I have 12 and now that I have 5, I can easily do Pythagorean Theorem one more time to determine what y is. And that would mean I would have 12 squared plus 5 squared equals y squared. 12 squared is 144 plus 25 equals y squared. And 144 plus 25 is 169. And then if you took the square root would be 13. So this baton could be 13 centimeters long, which maybe I should have wrote it as inches because that would be a super, super small baton of any kind. But just for the sake of this problem, that would be our final answer. Now we did talk about how there is a proof, though, for the shortcut. And our shortcut, instead of finding the 2 theorems, would be if we wanted to say, and sometimes they call it this, d squared equals, or not d squared, they're going to say d equals a square root of, and sometimes they say x squared plus y squared plus h squared. Now let me show you where they get that, but I'm actually going to use different letters. Let's say that we have A, B, this will be side C, this will be side D, and this will be side E. Okay? All right, and furthermore, let's go ahead and do our letters. This would mean it would be e squared is going to be the same as, and I'm going to change it to match my picture. I would have a squared plus b squared plus c squared. So the shortcut, once again, really quick, is just to add all three of these together, square them, and take the square root. Okay? So it would be 10 squared plus 2 square roots of 11 squared plus 5 squared. And if you took the square root of that, guess what else you're going to get? You're still going to get 13. Well, you might say, well, why do we even need to know Pythagorean theorem then? Why do we do that long way? Why did I have to find two triangles? Well, the shortcut, you're still using Pythagorean theorem, but it works for a reason, and I'm going to go ahead and I'm going to show why it works. I know that a squared plus b squared should equal c squared, right? Because this is my hypotenuse, these other two are my legs. I also know that if I want to figure out what e is right here, I know that it's going to be c squared plus d squared. That has to give it to me. Now, we talked about in math how instead of writing c squared for this problem, I know what c squared equals. So I can actually substitute a squared plus b squared into this term right here because I know this is c squared. This is another name for c squared. So if I scratch it out my second equation, I would really have a squared plus b squared plus d squared equals e squared. But to find plain old e, you would take the square root. And this actually proves why that shortcut works. So in class, as long as you understand the proof behind it and you can prove why it works, you do not have to do all of this work. What you can do, in fact, is you can go ahead and you can just write what this should be. And that would just be 10 squared plus 2 squared to 11 plus 5 squared. And the square root of that should give me 13. And another way you could even think about it if you wanted to, you could prove it like this in class. 10 squared plus 2 square roots of 11 squared is going to give me c squared. And then I know that c squared plus my d was 5 squared, should give me my e squared. Well, I know, once again, that c squared is this. So instead of writing c squared, I could write this in its place, substitute it in. Bam. Then you would have to take the square root of each side in order to get it, and that just brings you back. So whatever floats your boat, whichever one you like, that's the Common Core way. Hope you have a great day. Hope you have a good weekend, and I will see y'all Monday for class.